Welcome students. In our last lecture, we solved the linear first order differential equation of the form dy dx plus pxy equal to qx. So just let me recap the process. Suppose for example 1, for this problem, you need to first convert the equation into dy dx plus px into y equal to qx. Then you need to calculate integrating factor, that is e power integration px dx, because with respect to dx we are integrating. Okay, then you need to what will be our then after multiplying the integrating factor, the equation will be exact in nature, so we can write ddx of y into integrating factor equal to q into if. So if you integrate both sides, what you get, y into integrating factor equal to integration of q into integrating factor plus c. Okay, then you just solve it. So for this exercise you do in a same fashion and you will get the solution. Now come to our 2.25 article. Here our original differential equation not in directly in the form of linear differential equation, okay, general form of linear differential equation, but we may convert this into linear form. Okay, how? See the pattern. First, derivative of f. Suppose f dash y dy dx plus p f of y equal to q. Okay, p and q are constant or function of x alone. Okay, but not of y. You just remember this. Okay, q is a function of x and p is also function of x or constant. Okay, but here is any function of y, any form of f of y. It may be y, it may be 1 by y, it may be 1 by y square, it may be anything, any function of y, and its derivative is beside dy dx. Then we can convert it into linear form. How? If we take f of y equal to v, then what we have, if we differentiate with respect to x, so f dash y dy dx equal to dv dx. Now 1 becomes what? dv dx plus pv equal to q. Now this is in the linear differential equation form, whose integrating factor is what? E power integration p dx, e power integration p dx. So now this equation 2 can be written as v into if equal to integration of q into if plus c. Okay, understood? Now if in another form, the equation is of the form f dash x dx dy. Earlier it was f dash y dy dx. Now if the form is f dash x dx dy plus p1 f of x equal to q1, where p1 and q1 are constants or function of y alone. Okay, then if we put fx equal to b, what we get if we integrate with differentiate with respect to y, f dash x dx dy equal to dv dy. Then 1 dash gives dv dy plus p1b equal to q1. Okay, now what is our integrating factor? E power integration p1 dy. Okay, so that we can write 2 dash as v into if equal to integration q1 if plus c. Okay, now let us do a special form, that is called Bernoulli equation, where dy dx plus py equal to q y power n. Okay, so q is p and q are any function of x alone, right? Not of y. And n is constant except 0 and 1. Okay, n is constant except 0 and 1. Then we need to free y in the free q in the right hand side, so just divide by 1 by q. So what will be that? y to the power minus n dy dx plus p y to the power 1 minus n equal to q. Now y to the power 1 by n is like any function of y, so just put it as v, and its derivative is y power minus n dy dx, and in the right hand side you get 1 by n 1 minus n into dv dx. Now put all these values in 2a, what you get? dv dx, and make conversion, you get dv dx plus p into 1 minus n v equal to q into 1 minus n, right? Now you this is linear differential equation in v. So calculate the integrating factor. e power integration, that means the whole px into dx. So you get this, that is your required solution. So now v into if equal to integration of q into if plus c. After calculating you get the solution. Okay, in the same manner you can do for dx dy plus p1x equal to q1 x power n also. So just divided by x power n, so this will be x power 1 minus n and put it as v, then in the same manner you can get the solution. So do one example. So solve this dy dx plus, this is what, p of y, sorry, x into f of y equal to x cube cos square y. So now we need to free x cube, na? Function of x alone in the right hand side. So divided by cos square y, what you get, sec square y dy dx plus twice x tan y equal to x cube. Now what we need to put, the function of y should be put as v, na? So tan y should be put as v and its derivative sec square y dy dx equal to dv dx. So now equation 1 becomes dv dx plus twice x v equal to x cube. Now this is the linear differential equation in v. So its integrating factor is e power integration px dx, that is twice x dx, so that is e power x square, and its solution is given by v into e power x square equal to integration x cube into e power x square dx plus c. Okay, now you just take x square equal to t, so that twice x dx is equal to dt, and just do the, this is polynomial, so apply the Bernoulli rule that I already told you for integration, and you get the final answer. Now what you have to remember is that you need to convert this v into the original function that you assume, like v equal to tan y. You next replace the v as a tan y. So tan y into e power x square equal to half, and you put for t equal to x square, so e power x square into x square minus 1 plus c, right? That is your answer. So do these problems. Okay, so all the problems are same, just you need to follow the rule only. Okay, so this is your homework of exercise twice L. Now you see this example, x dy dx plus y equal to y square log x. Okay, now in the right hand side you need to have, because this is dy dx, you just see dy dx, so in the right hand side you not need only have the function of x alone, so divided by x. Okay, so what you get, and divided by x y square, so that right hand side is clear of function of x. So in the right hand side will be 1 by x log x, and left hand side will be 1 by y into 1 by x into y power minus 2 dy dx. Now you need to take function of y as a b, so that means y power minus 1 is b, so that y power minus 2 dy dx equal to minus dv dx. Then one gives what? This equation. So this is a linear first order differential equation in v. Now integrating factor e power, because we are differentiating with respect to x, so e power integration of minus p dx, that means 1 by x. So solution will be v into 1 by x equal to minus integration x power minus 2 log x dx plus c. Okay, so after integrating you get up to this. Now again you need to put replace the v by 1 by y, so that you get the final answer. And final answer is 1 by y equal to log x plus 1 plus cx. So you need to remember how to do the integration here only. Okay, similarly suppose dy dx minus y tan x equal to this function. Okay, so here you see you need to, because this is dy dx, so you need to x free in the right hand side, so you need to divide by y square. What you get, right hand side minus sec x, left hand side y power minus 2 dy dx minus tan x into y power minus 1. Now function of y should be put as v, that means y power minus 1 equal to v, so that you get 1 by y square dy dx equal to minus dv dx. So 1 becomes what, dv dx plus tan x into v equal to sec x. Now this is the linear differential equation, first order differential equation in V. So if equal to integration e power integration px dx, that means e power integration 10x dx. So that is sec x. Okay, so V into sec x equal to integration sec x into sec x dx plus c, that means sec square x dx. So it's integration 10x. So you just replace V by 1 by y. So what you get? 1 by y sec x equal to 10x plus c. Okay, so this is these are some problems. In a same manner you solve all these problems, and also this exercise also. Okay, so exercise twice. So for your so if you have any doubt in our live class, you can tell me. Also you can call me at any time. Okay, so do all these problems. Okay, thank you.